In this demo, we'll show you how to build a predictive model using housing data from 5,000 homes. The data is provided in an Excel file, which we will process. The first step in building the model is to load the data into a data frame. A data frame is stored in memory and allows us to manipulate the data for building the prediction model. Let's run this Python pandas code to read the data. The output shows that the dataset contains 5,000 home observations and 7 columns or features. Exploratory data analysis, EDA, is a crucial part of AI training. Understanding key statistics like the maximum, minimum, and range helps us gain insights into the data. For example, in this dataset, we find that the maximum price is $2.4 million, while the minimum price is $15,938. Next is feature selection. Which features are most important? While many factors might influence the price of a home, some may be less significant than others. In this case, based on my expertise, I've decided to focus the prediction model on the age of the home and the number of rooms. This means that with just the age and number of rooms, we can predict the home's price. In machine learning, it's common practice to split the data into two sets to ensure the trained model performs well. We use the training data to build the model and the testing data to evaluate its accuracy. However, in this demo, we will focus only on training the model and will not use the testing data. One of the most time-consuming aspects of data science and AI is data preparation. Data columns can have different ranges and data types. Some are numbers, others are categories, and some are just text. To simplify the analysis, it's crucial to standardize the data. For this demo, we'll assume all the data is numerical, and we'll use library functions to scale it. This means we'll adjust the data to fall within the range of 0 to 1. In order to apply the machine learning algorithm, we need to combine the scaled data vectors into a single data frame. We will use a method called linear regression, a method that identifies a linear relationship between independent variables, x, and a dependent variable, y. While we'll skip the technical details of how the model is trained, the key point is to find a model that best fits the data. The model coefficients represent the strength and direction of the relationship between each independent variable, input, and the dependent variable, output. Each coefficient indicates how much the dependent variable is expected to change when the corresponding independent variable increases by 1 unit. Now that we have the model coefficients, we can use them to estimate the price of a new home based on its specific features. By inputting details like the home size, number of rooms, location, and other relevant characteristics into the linear regression equation, the model will calculate a predicted price. In summary, we started with a data set of 500 homes, each with 6 attributes, such as age, number of rooms, etc., and the corresponding price. Our goal was to learn how to estimate the price of a new home based on specific attributes like age and number of rooms. We used 4,500 data points, scaled them, and trained a linear model. We then used the model to estimate the price of a new home that is 3.9 years old with 4 rooms. The estimated price was $524,092. You can experiment by changing the home's age and number of rooms to see how the price varies. It's also worth noting that the age of the home has a greater impact on the model, so 0.45822,694, compared to the number of rooms, 0.36817,577. If you're interested in accessing this online notebook for free, please fill out the form provided in the video description to get access to codebench. We'll contact you with the details. This video is sponsored by Qubits.ai, a Princeton University startup.